Let's talk about how to calculate the margin of error and determine the confidence interval. On the screen are two formulas. The first one is the sample mean, and we're going to both add and subtract the z-value, and I'll talk more about that, times the population standard deviation divided by the square root of n, and n is your sample size. The second formula is p. Again, I'm going to add and subtract the z-value times the square root of p times 1 minus p divided by n. Which formula you use depends upon the information that you're given in the problem. From now on, whenever you read a summary of or abstract or the entire public opinion poll or an article in the media, you will always see, and you should always look for, that paragraph that talks about the sampling method and how they calculated the margin of error and the confidence interval. Public opinion polls are based on information collected from a sample of individuals, not the entire population. So there's always going to be a degree of error that we call sampling error or the margin of error. Sampling error or the margin of error is simply the price we pay for not being able to be perfect. We are not able to survey or interview every member of the population. So what z-value do we use? That depends on what level of confidence we wish to achieve or obtain. For a 95% confidence level, the level we use most often, the z-value is 1.96. If we want a 99% confidence interval, we use the z-value of 2.58. We don't usually use 99% confidence level because while we want a higher confidence level, that means we have to increase the z-value to 2.58. Increasing the z-value also increases the margin of error, and that results in a wider confidence interval, which we don't want. We want to narrow it as one as we can possibly get. Go to the unit normal table and look in the first column for z-values, and you will see 1.96. Go to column D, which is the proportion between the mean and the z-score, or z-value, and you will see 0.4750. Since, again, the normal distribution is symmetrical, there is a distance between z and the mean on both sides. So you simply add 0.4750 or to each other, or multiply by 2, and you get 0.95. Do the same for 2.58 and you get the same result, the 0.99. That's where it comes from, the unit normal table. Let's try a sample problem, and I apologize, the felt tip pen I used was green, so it's not showing up as dark, but here we go. You have 100 used cars, that's your N value, on a car lot containing 1,000 cars. The standard deviation is equals 500, and the mean, which is the average mileage on the cars in the sample, is 30,250. We want to know what is the 95% confidence interval for average miles on all cars in the lot. So first we have to calculate the margin of error. And our formula is simply 30,250, the mean. We're going to add and subtract 1.96 is the z-value for a 95% confidence level, times 500, the standard deviation, divided by the square root of 100. Square root of 100 is 10, so 500 divided by 10 equals 50. 1.96 times 50 equals 98. So we are going to add and subtract 98 to and from the 30,250 to get your confidence interval. The margin of error, or sampling error, is the 98. So we have a confidence interval of 30,152 to 30,348. We are 95% confident when we do this process that the mean will be within this interval. That also means that 5% of the time we are going to have sampling error and we will be outside of our confidence interval. But 95% of the time is a pretty good batting average. Now let's use the other formula. If you are given a proportion or probability or percentage, you will use the second formula. For example, let's say we have a sample of 1,000 college students with 28% of them watching the Super Bowl each year. We want to find the 95% confidence interval for the proportion of all college students who watch the Super Bowl. So N equals 1,000, P equals 0.28. We had to convert the percentage back to a decimal. We're going to use the formula P plus and minus Z value times the square root of P times 1 minus P, all divided by N. So we'll have 0.28 plus or minus 1.96. Again, we're using a 95% confidence level, times the square root of 0.28 times 1 minus 0.28, all divided by 1,000. You'll have 0.28 plus and minus 1.96 times the square root of 2 10,000ths, or 0.0002. That will give you plus or minus 0.028. So we are going to add and subtract to and from 0.28, the 0.028. And you get a confidence interval of 0.252 to 0.308, or 25% to 30.8%, which is, again, we all like to look at the percentages. But the margin of error is the 0.028. Sorry. Let's try one more example. Election poll. Sample of registered voters, 1,000. We want a 95% confidence level, so our Z value will be 1.96. The question is, do you approve of President Obama's job performance since he took office? 520 of the voters who were surveyed up from the 1,000 said yes. First, we have to calculate the margin of error. But before that, we have to know what P is. And P is simply 520 divided by 1,000 equals 0.52. So P is going to be 52%, but we're going to use the 0.52 decimal. So we'll have 0.52 P plus minus 1.96, the Z value, times the square root of 0.52 times 1 minus 0.52, all divided by 1,000. And that should give you 0.031, or 3.1% is your margin of error. Adding and subtracting 0.031 to the 0.52, you get 49 to 55% is your confidence interval. Based on this computation, we're 95% confident that the sample mean will be within this interval. And that's all there is to computing a confidence interval. You determine the margin of error and you add and subtract. And that gives you this interval of probability that helps us be confident about some of these predictions that we come up with through polling and other surveys.